Alright, so today we're going to finish up this quadratic applications worksheet by talking just a little bit about quadratic regression. It's very similar to linear regression that we've done before, except we're doing quadratic regression. So, we're going to look at number 21, and we're going to do number 21 in this video. And we've got two projectiles. One of them is described by that equation, and the second one is defined by this set of data in this table. So we are going to answer these questions based on those. So we're going to go to the graphing calculator, and on the graphing calculator, I'm sure you've got some stuff on there. So what we're going to do is just clear out any equations we have in there. And then what we're going to do is we're going to put that first equation into y sub 1, the 64x minus 16x squared. So we've got 64x minus 16x squared. And then for the data, what we're going to do in number 21 is we are going to enter that data into our lists. So as a quick refresher, how you get to the lists is you go to the stat button, which is right next to the variable button that we use, and hit enter on edit. Now, it's possible you may have some data in those lists, so to get rid of that data, you arrow up until the heading, or L2, is highlighted, and you hit clear, enter. And then you do the same thing for list 1. Hit clear, enter. Make sure you don't hit delete when the list 1 and list 2 are highlighted. That'll get rid of the heading as well, and you don't want that to happen. So make sure you use clear and enter. So I'm going to enter the times into list 1. So half a second, 1 second, 1.5 seconds, and 2 seconds. And then the corresponding heights will go into list 2. The 20, 32, 36, and 32. All right, so if I just, I'm going to go ahead and turn my plot on. So I'm going to go to y equals, up arrow, and hit enter while it's flashing on plot 1. There we go. And I'm just going to hit zoom 9. Okay, now that blue graph there, you see, that's actually the first one. Okay, so I'm going to expand my window. I need to increase my X max and Y max to include that first graph. So I'm going to take it out to maybe like 6, just to see. And I'm going to take the Y max up to about 60. And then I'm going to hit graph, and I still have those 2 dots. Okay, I see most of that parabola, but not quite all. So I'm going to go back to my window and readjust to 70. Or I'm sorry, 75. And now I see that entire parabola. Okay. And then, so it's obvious that the projectile described by the equation goes higher than the one described by the table of values. Okay. But what we're going to do right now is we are going to find the quadratic equation that describes the height of the projectile described in the table by these different data points. So we're going to run quadratic regression, and in order to do that, we go to Stat. We're going to scroll over to Calculate, and again, this is where the linear regression was that we did earlier, except we're going to do quadratic regression, which is choice number 5, the quad reg. So that's choice number 5, and yeah, we're doing the regression to list 1 and list 2. And we're going to store the equation, except we're not going to store it in y sub 1 because we already have our other equation there. So we are going to store it in y sub 2 instead. And then we're going to go ahead and calculate that. So that is the equation. Basically, it's going to be negative 16t squared plus 48t. So I'll go back here and write that down. The equation for this, the height of this object is equal to negative 16t squared plus 48t. That is the equation that describes the projectile in the table. So when we go back to the graph now, we see that our equation that models the data points, got a little nervous there, it took a little too long, is now graphed. So now we can calculate the maximum height to answer part B, because part D we already know, or part A we already know the answer to. That's the projectile in the equation is higher, or goes higher. So how much higher? Well, let's calculate each maximum. So for the equation, the projectile in the equation, that's a blue line. And then we're going to also for the red line. So let's calculate the maximum of the blue graph first. So we're going to calculate the maximum of the blue graph. And again, it's going to ask you for a left bound and then a right bound. Oh, it didn't catch my enter there. There we go. Now we got that vertical line, and then it's going to ask me for a right bound, and then the maximum for that first one is 64 feet. So I'm just going to write that down. The equation is the maximum height is 64 feet. And then for the table, what I am going to do is go back here, and I'm going to calculate another maximum. Except I don't want to do it to y sub 1. I'm going to down arrow here until I get to y sub 2, and that's the one I want to find the maximum of. Okay. Again, it asked me for a left bound and also a right bound. And the maximum of the second one is 36 feet. So I'll write that in red since the graph was in red. So how much higher is the first one than the second? Well, that's 28 feet higher. And then at what times is a projectile at a height of 16 feet? Well, we'll do the equation one first. So what we're going to do is we're going to go back to our calculator, and in y equals, we're going to put a third equation of 16. And we will hit graph. Okay. Now, we're not seeing that third equation yet, so we're going to go back to our window, And we'll notice that the y min right here is 17.28. It's too high to see that line at 16, so I'm going to scroll down and let's go down to 10 just so we can see that that third graph. There's the third graph. Now the only issue is we're not seeing where it crosses the blue graph over here. So I'm going to move this screen to the left a little bit. So I'm going to move that x min. I'm going to move that to, let's say -1. There's the blue graph. And then the red graph that we found using the quadratic regression. And we've got our 16 line, which crosses both of those twice. So I'm going to calculate the intersection with the blue graph first. So here's kind of where you have to be careful. I'm going to calculate an intersection. Just choice 5. And I'm going to calculate the intersection with the blue graph. So yes, but not with the red graph. So I'm going to down arrow to get away from that. And yes, the black graph of y equals 16. So one time when that blue graph is 16 feet off the ground is about 3.73 seconds. So I'm going to just go back and write that down. So for the blue graph, one time that it's 16 feet off the ground is 3.73 seconds. And then there is a second time where that happens too. So I'm going to calculate an intersection again. The blue graph, yes. Not the red graph, so I'm going to down arrow from the red graph. Black graph, yes. And now what I'm going to do is right arrow until my little flower, or X there, gets closer to that other intersection of these two. And the other intersection is about 0.27 seconds. So that first projectile is 16 feet off the ground twice, once at 0.27 seconds on the way up, and the other time at 3.73 seconds on the way down. So now we're going to do the same thing except with the red graph. We're going to find when this red graph is 16 feet off the ground. So for this one, we're going to calculate a couple of intersections again. So we're going to calculate an intersection. First curve, we don't want the intersection of the blue graph, so we're going to down arrow. We do want the intersection of the red graph and the black graph. So we're going to hit enter on both of those, and then hit enter on our guess. So the red graph is 16 feet off the ground at 0.38 seconds. That's when it's on its way up. So 0.38 seconds on the way up. And then on the way down, we're going to calculate that intersection for that second intersection, 5. Now the blue graph is not one that we want to calculate the intersection of. The red graph is, so is the black graph. But now that we're on our guess, we want to right arrow until we're closer to that other intersection. And that happens again at 2.62 seconds. So we're going to go back, and that's at 2.62 seconds. Okay. So that's how we can run quadratic regression, make some predictions, and so on. We could make some predictions. How high is this off the ground at 2.5 seconds or even 3 seconds? So we can do things like that. That's just kind of a refresher course. The only difference between this quadratic regression and linear regression is which regression you choose to run out of your regression. That's the only difference. So that's quadratic